Hello, ladies and gentlemen, and welcome back. Welcome back to more of the 2016 Canadian Senior Math Contest. We are up to question number 4 in the Just Give Your Final Answer section, Part A. So we've got the figure, called a net, has dimensions as shown. So you've likely seen nets before. I mean, I saw them when we first started getting introduced to 3D solids way back, very early public school. I'm talking grades 2, 3, that sort of thing. And we would cut out little square nets. Little nets for cubes, but they consisted entirely of squares. But if you want to make a rectangular prism, as this question's talking about, you get more, weirder shapes. Okay? But the thing is, this question, at least... Let me... Slow down. Let's finish reading the question. So the figure has dimensions as shown. This net can be folded to form a rectangular prism. What's the volume of the prism? Okay. So I think the key to this question is being able to understand how a 2D net can become a 3D. You fold it up and it becomes a 3D solid. Okay, so this 3D solid, which we can, get question 3 out of the way. Okay, so our net here, which I'll draw in a moment, forms a rectangular prism. And it's very important that we understand how the 2D picture can go to something that has dimensions x, y, and z, because that's the only way to figure out the volume of a prism. Okay? The volume is x times y times z. So the question is, well, how do I figure out the x, y, and z? And in theory, there's a way to do it. So we have a nice thin bar, and then we've got a few things sticking out. Okay, so thin bar, and I want to try and draw this fairly accurately. So fat bar. Okay, sorry. This is the tall one. We'll make this one sort of fatter. Fat, thin. Okay, so it looks something like that. Alright. So we need to sort of fold this mentally. And what we need to realize are these rectangles that make up our net correspond to faces on our prism. And that's what we need to realize. So, for example, I mean, these two blue ones that I have here are going to be the top and bottom. Okay? And these, let's make them purple. These ones form the band between the top and bottom. Okay? So if we associate that to our picture here, the top and bottom have dimensions x by y. Well, let's just label one of these x. And so the other ones are all y's. But because this guy here is an x, and we've got a rectangle, this has got to be an x. Okay? And these two fold to match up. So this is an x, and this is a y, and this is an x, and this is a y, and that makes this y. Okay? But these two have to fold up, so that makes these guys x's. And these two have to fold up together, so that makes these y's. Okay? You could, in theory, if somebody lets you have scissors on the contest, you could cut out a fair approximation of this and start folding it up. But not all people, not all proctors allow scissors and things like that, and you might not have enough scrap paper left to do something like this. So what I would suggest, if you're bad at this sort of spatial stuff, and you know that these questions might come up from time to time, I would explore nets on your own. Try and be able to take a picture of a net, a mental picture, and fold it up inside your head. Okay? And, this can be done by going online, just looking for some basic net construction paper style materials. Yeah, it'll be aimed at very low grades and that sort of thing, grades 2, 3, 4, that sort of thing. But printing those out, cutting them out, and exploring with them on your own as a form of study is a great way to get this sort of spatial awareness, 2D to 3D style things cemented in your brain. Okay? But other than that, all you can really do is say, well, how does this picture form this one? Well, certain sides fold together. And so all of these side lengths here are now the z's. Okay. So now what can we do? Well, we are told things in our picture. And because we now have things labeled, we can understand and put formulas to these lengths. So we have 14, 11, 38. So we have 38, we have 14 over here, and 11. But now that we have it labeled, we know this 11 is a z plus an x. We know this 14 is z plus a y. And we know this 38 is x plus y plus x plus y. So that's 2 x's and 2 y's. I'm going to divide this by 2 to get 19 is x plus y. Okay? So now I have 3 equations. 11 is z plus x, 14 is z plus y, and 19 is x plus y. I'm going to use these 3, and I'm going to individually figure out x, y, and z. There's lots of ways to do this. What I'm going to do is I'm going to add them all up. So x plus y, x plus z, and then a y plus z. I'm writing these stylistically so that the same variable is grouped in columns. We got 19. I genuinely don't remember which one was which. X and z is 11. So x is the smaller of x and y. 11 and 14. But now if I add these up, I've got 2 x's, 2 y's, 2 z's. 19 plus 11 is 30, plus 14 is 44. Divide by 2, I have x plus y plus z is 22. And you might say, well, what good is that? You've put all 3 together. But now I can take each one of my already known formulas, so x plus y is 19, and subtract them, and it'll just leave the other variable out. So z is equal to 3. Because 22 minus 19 is 3. X minus x is 0, y minus y is 0, z minus nothing is still z. Or if I want to do, there I've got z, so now I can just take this and plug it back in, but I could also do something like subtract x plus z from here, and realize that y is left over, and y is 11. And then I could also figure out the last one. I could figure out x itself by subtracting off the y plus z, which is 14, and I'll get x on its own is 8. And we do a quick mental check. I mean, I know it's only question 4. It's not a particularly challenging one. 5 should be harder. 6 definitely will be hard. 1 in part B is kind of easy, but 2 and 3 can be more challenging. But still, you don't want to make a little mistake at this stage, especially if you're one of those people who just wants to put the final answer and move on with it. I don't recommend you do that. I do recommend you leave a little bit of explanation for part marks in case you mess up. Yeah, it looked fancy if you just scribble in your answer, but you are doing a gamble. No matter how confident you are doing a bit of a gamble. Gambling 5 marks as opposed to a few part marks with a little less time. So I would at this stage, now that I think I've got them, just very quickly plug them back in. X plus Z, 3 plus 8 is 11. 11 plus 8 is 19. 3 plus 11 is 14. So yes, these X, Y, and Z are correct. And now finally, we want the volume, at long last. That's x times y times z. That's how we get the volume of a rectangular prism. So that's 8 times 11 times 3. 8 and 3 is 24. Times 11 is 24. It's going to be 4, 6, 2, 6, 4. There we go. So 264 is our final answer. That is the volume of a rectangular prism. And this question required obviously a little bit of algebra if you take a look at this page, but certainly spatial reasoning, being able to go from a 2D net to a 3D picture and understanding how the dimensions on the 2D picture are created with the dimensions of our prism. So I actually think that's a fantastic question. I really like this question. It's algebra and spatial awareness. And you don't often get on the senior contest a lot of spatial awareness questions, but I think that's pretty nice. So, what else is there to do? Well, nothing with question 4, but everything with question number 5. Feel free to give that one a bit of a try before I get to that in the next video. I'll see you guys then.